Am I audible, guys? Am I audible? Hello. Some network issue might be there, okay, from my side. Audible, right? So, so whatever your matrices topic was there, I completed the other day. So today we have to just solve questions. And nothing extra theory is remaining. Okay, fine. So try to solve this question, guys. If determinant of A3 cross 3 is equals to -2, the value of determinant of adjoint of 2 times of 3A whole inverse into 4 times of A, 4 times of A का whole inverse, okay, into adjoint of A का determinant is equal to, here I'll write down, -1 to the power of alpha, 2 to the power of beta divided by 3 to the power of gamma. Then find the minimum value of alpha plus beta plus gamma, okay, where alpha comma beta comma gamma belongs to natural numbers. Try to do one similar kind of problem we had done. Yeah, anyone getting answer? Okay, fine. So see here, we know the property that determinant of A into B into C is equals to what? Determinant of A into determinant of B into determinant of C. Fine. So here they are telling that A is a 3 cross 3 matrix, then adjoint, inverse, adjoint of adjoint, all will be 3 cross 3 matrices. Fine. So definitely I can come and do what over here. I can write it down as determinant of adjoint of A to A 2 times 3A का whole inverse into determinant of 4A का whole inverse into determinant of adjoint of A. Correct? Now we can use the properties easily and solve it. Correct or no? So first one, if this I am solving, okay, so if I solve this, it will be nothing but what? Determinant of 2A, 2 will come outside. Correct? So next, adjoint car outside 2 came. Then what it will be? 2 came outside adjoint. So it will become what? Square, no? Because A is a 3 cross 3 matrix. We learned the property that adjoint of A is a determinant of, sorry, adjoint of K times A. Adjoint of K times A will be equals to K to the power of n minus 1 times adjoint of A. Correct or no? So here also same thing. 2 square will come out. Adjoint of 3A ka whole inverse. Okay. So now from here see 2 square will come out. So it will become what? 2 square to the power of 3. Correct? Times adjoint of 3A ka whole inverse. Understood guys? Okay. Now this adjoint of 3A ka whole inverse we have to remove. How can we remove? See, we know that determinant of adjoint of A is equals to what? Determinant of A to the power of n minus 1. Correct or no? So same thing here also it will be nothing but what? 2 square will be 2 to the power of 6 over here. Now this value, see here, adjoint of 3A ka whole inverse will be nothing but what? Determinant of 3A to the power of minus 1 to the power of 2. Clear, all the properties are revised in this single question. So from here, now, next what I can do, I can take it to denominator and go. I know that determinant of A inverse is same as 1 by determinant of A. Correct. So here also it will become what? Square is there. So 2 to the power of 6 into determinant of, or 1 by determinant of 3A ka whole square. Understood? So now finally 2 to the power of 6 divided by this 3 will come outside. It will come out as 3 cube, but also square is there, no? 3 cube. So 3 to the power of cube into square will be 3 power 6. Understood? Or it will be 3 power 6 into determinant of a square. Correct? Now determinant of a is nothing but what? Minus 2. So 2 to the power of 6 divided by 3 to the power of 6 into minus 2 to the power of square. Yeah. So how much it will be? You can calculate other terms also. Anyone got the final answer? Minus 4. No, wrong. So first term ka value we have 2 to the power of 6 divided by 3 to the power of 6. I'll keep as determinant of a whole square only, okay? Because it is getting cancelled over here. See. Next we have determinant of 4a ka whole inverse. Correct, no? Yes. Determinant of 4a ka whole inverse. So which can be written as 1 by determinant of 4a. So 1 by 4 will come outside. It will become 4 to the power what? Cube into determinant of a. Fine. So 4 to the power of cube divided by, sorry, 1 by 4 to the power of cube divided by determinant of a into last term is 1 meter. Yeah, solve guys correctly. Answer is not 4 or minus 4. Try, okay? 1 minute, I'll be back. Okay, fine. So next is determinant of adjoint of a. Okay, which is nothing but determinant of a. Correct? N minus 1 to the power of square. That is 2 to the power of square it is. Correct? So which will be nothing but what? Determinant of a to the power of 4. Yes or no? So here we have determinant of a to the power of what? 4. So here we have what? A square. Here we have determinant of a. It will get cancelled. Only determinant of a will remain. So finally it is nothing but what? See, 2 to the power of 6 divided by 3 to the power of 6, 4 to the power of 3 into determinant of a. So 2 to the power of 6 into minus 2 divided by 3 to the power of 6 into 4 to the power of 3. Clear? Now further if we simplify this, how much we'll get? This can be written as 2 to the power of 6 into minus 2 divided by, see, 4 can be written as 2 square. So 4 cube will be nothing but what? Whole cube, which is 2 to the power of 6. So here also we'll get 2 power 6, 3 power 6. It will get cancelled over here. Correct? So finally we will have minus 2 divided by 3 to the power of 6. So they are telling that it is of the form what? Minus 1 to the power of alpha, 2 to the power of beta divided by 3 to the power of gamma. So if we see the values here, alpha value is what? This can be written as minus 1 to the power of 1, 2 to the power of 1 divided by 3 to the power of 6. So alpha value is 1, beta value is 1, and gamma value is 6. So if we add this all, alpha plus beta plus gamma value is what? 8. That is what they are asking. Find the minimum value. Belongs to natural numbers. No, they all got wrong. Okay, answer is 8. Fine. Chalo. Next question. So write down some result, guys. This is one result. Anyhow, in determinant again, mostly it will come. But still, first result. If A into B is equals to 0, if A into B is equals to 0, then both are singular matrices. That is, determinant of A is equals to 0 and determinant of B is equals to 0. Okay? If AB is equals to 0, and this is for square matrix. Okay? Square matrices. Second point. If A is not a null matrix, if A is not a null matrix and B is non-zero, then if AB is equals to 0 implies that determinant of B should be equals to 0. Third, if AB is equals to 0 and determinant of A is not equals to 0, then B should be equals to null matrix. These are the three results. And square matrix, obviously. Okay. Next, try this question. If P and Q are two square matrices of order 3 cross 3 such that P is not equal to Q, P cube is equals to Q cube, and P square Q is equals to Q square P, then find determinant of P square plus Q square. Okay. Subjective question. Try this question, guys. I'll be back. You got anyone answer? Anyone for the answer? Same like vectors, something like vectors. Okay. So see here, they're telling that P is not equals to Q. Correct or no? P is not equal to Q. So this implies what, guys? Both are matrices of same order, 3 cross 3. So P minus Q is also not equals to 0. Correct or no? This is first. Second, they're telling P cube is equals to Q cube. Correct? Again, what they are telling? Third, they are telling that P square Q is equals to Q square P. These 3 points they are telling. Now, if I subtract this both, okay? If I subtract this both, what I'll get? P cube minus P square Q is equals to what? Q cube minus Q square P. Again, take P square common. What I'll get? P minus Q. From here also Q square common I can take. What I'll get? Q minus P. These are all because of what? Matrices are of same order. Okay, you can multiply again, you'll get back same property. Correct. So next, if I'm bringing this side now, P square P minus Q minus Q square Q minus P is equals to what? 0. Correct or no? So now this whatever minus is there will multiply inside. So it will become what? P minus Q again. So P square P minus Q plus Q square P minus Q is equals to what? 0. So P minus Q I can take common now. The remaining will be what? P square plus Q square is equals to 0. Now if you see over here, I'll apply determinant on both the sides. Okay. So here also determinant of 0 is nothing but what? 0. It will be a null matrix. Fine. I'll write down like this. It will be like this. It will be a null matrix. Understood? So from here, it is clear that determinant of AB is equals to 0 is that nothing but what now? What I can tell? See, already P minus Q, we have told it is a non-zero matrix. Correct or no? Then what should be equals to 0? Just now we learned the property. If a determinant of AB is becoming equal to 0, okay, somewhere I have missed something. Yeah, one sign I have missed, guys. If AB is equals to 0, then both are singular matrices. That is determinant of A is equals to 0 and determinant of, okay, here it should have been or. Instead of and, it should have been or. Okay. Wait a minute. Okay. We'll extend this property, guys. Let us tell that if, see here I'm continuing it. If A is not equals to 0 and B is not equals to 0, but A into B is equals to 0, then both are singular matrices. Okay. That is determinant of A is also equals to 0 and determinant of B is also equals to 0. When it is possible, A and B both are not equals to 0, but their multiplication AB is equals to 0. Understood? One meta. Okay, fine. So understood, no? So from here also same thing see now. determinant both p minus q is not equals to 0. P square minus q square ka we don't have idea. It may be 0 or it might not be 0. So from here, p minus q determinant can be equals to 0, and your determinant of p square plus q square is equal to 0. So that is what we had to find. Correct or no? Understood? So like this, see, just by adjustments, we'll get the answer. And for sure, we know that this is a non-zero matrix. Or a second property also you can apply. Second property, what it says, guys, see, if A is not a null matrix and B is a non-zero matrix, then if AB is equals to 0, either that determinant of B should be equals to 0. Correct? Next question. If A is a square matrix of order 2 cross 2, such that A square plus A plus 2i is equals to 0, then which of the following is incorrect? Option A is singular, A is non-singular, A square plus A plus I is equals to A minus I to the power of minus 1, A plus I whole square. Yes. Wait a minute. Yeah, got the answer. Anyone? If A is a square matrix, see they are telling that, I'll give you a hint. They're telling A is a square matrix of order 2 cross 2. They have not told that it is zero matrix or null matrix, anything. They are telling it is satisfying this equation. Then which of the following is correct? Okay. Incorrect. Sorry. You have to tell. Incorrect. It might be multiple select question. Multiple answers might be correct for this. See, one thing you observe, guys, here. This equation is given, right? So from here, I can write it down as what? A square plus A, correct? Is equals to minus 2i. Can I write down like this? Yes or no? Now from here, if I take A common, it will be A plus what? I is equals to minus 2i. Now from here, see, if I take determinant on both the sides, determinant of A into A plus I is equals to what? Determinant of minus 2 times I. Correct or no? Now, here from here, see here, A into A plus I is there. Definitely can be written as determinant of A into what? Determinant of A plus I is equals to what? Minus 2 will come outside. It will become minus 2 square because it is 2 cross 2 matrix into determinant of I. Determinant of I is nothing but what? 1. Correct? Now from here, see, this is at least definitely not equals to 0. Yes or no, guys? Because why? Even though your A is a 0 matrix, you think. So determinant of A plus I will not be equals to 0. Sure shot, I can tell that. Clear? Okay. Next. Now in question they have not mentioned anything. A is a square matrix of order 2 cross 2. That's it. Nothing else has been mentioned. Non-zero matrix also it can be, zero matrix also it can be. So further from here what we can tell now, see we are getting determinant of A into determinant of A plus I as equal to 4, which is not equals to 0. So what can I confirm from here? Yes, what we can confirm guys from here? Can we tell both are not equals to 0? Can we tell from here this is also not equals to 0 and this is also not equals to 0? Because we are getting as equals to 4. If one of them is also equals to 0, will not get equals to 0. Correct or no? Yes, definitely we can tell no. A into B, if it should not be equals to 0, then both of them should not be equals to 0. Yes, yes, yes. Correct. So from here, this implies that what now? This implies that if determinant of A is not equals to 0, then this implies A is a non-singular matrix. See, done. Means this is true. Okay, so this option can't be correct. Now, if A is non-singular, we further know that A inverse exists. Correct or no? A inverse exists. Yes. If A inverse exists, further what we can tell? This is the given equation. A square plus 2A plus I equal to 0. I can multiply this equation by A inverse and take. This is what you people used to do to find the inverse of the matrix, right? So that I can verify option D is correct or not. In your regular classes, class 12, you would multiply this equation by A inverse. So if I multiply, because A inverse exists, first I found that A inverse exists or not. A inverse exists, so if I multiply over here, it will be A inverse into A square plus 2 times of A inverse into A plus A inverse into I will be A inverse equal to 0. So from here, what we'll get? This will be A plus 2I plus A inverse equal to 0. So from here, A inverse will be equals to what? So this will come this side. It will be minus A plus 2I. Correct? But here what that again? A inverse is equals to minus 1 by 2. Where I have done mistake. Equation wrong I have written. Okay, sorry, it is A square plus A plus 2I. A square plus 2A plus 2. A square plus A plus 2I equal to 0. Correct? So means this 2 will not come. Here we will get a 2. Correct? 2. This 2 will not come. So 2A inverse is equals to minus A plus I. Correct? Or A inverse is equals to what now? 1 by 2 times. Okay, minus A minus I it will be. Minus can be taken common. So minus 1 by 2 A plus I. Means your option D is also what? True. Okay, this can't be correct. Now two options you have. A square plus A plus I is equals to A minus I whole inverse into A plus I whole square. Try to solve. Other two options. Try. See guys, can we solve it from this given equation? See here. A square plus A plus 2I is equals to 0 is there. So which can be written as what? A square plus A plus I can be written as I plus I because they are telling A square plus A plus I. Correct, no? A square plus I plus I equal to 0. Now further see what adjustment I am doing. Your A whatever is there, A square, A can be written as plus 2A minus A and plus I equal to 0. Understood, no? Why I am doing like this? Next, see from here, I can take this common terms, that is A square plus 2A plus I can be written as I square also. Okay, equal to, this will come this side, it will become A minus I. This is nothing but what? A plus I whole square is equals to A minus I. Yes or no? Correct. So from here, if I do the adjustment again, what adjustment can be done, because here it is a plus I whole square is there, a minus I ka whole inverse I want. So from here, if I multiply both the sides by a minus I ka whole inverse, understanding, no? Multiply both sides by a minus I ka whole inverse. So see what we'll get from here, a plus I ka whole square, left side or right side it is, a minus I ka whole inverse, a plus I ka whole square. And here also it will be nothing but what, a minus I into a plus minus I ka whole inverse into a minus I. Now this is nothing but what, a minus I ka whole inverse multiplied by a plus I ka whole square is equals to what? This is nothing but what? Tell. It is identity matrix, a into a inverse, identity matrix. So this value whatever is there, we are getting it as what? Identity matrix. So if this is identity matrix, then what will happen, guys? This is true or false? False, no, definitely, because here see we have a square plus a plus I you add on both the sides. A square plus a plus I. You add I on both the sides. It will become what? 2I. So here it will become what? A square plus a plus 2I equal to, you'll get 2I. But actually we should have got what? 0, no? Null matrix. So this statement is obviously what? False. So incorrect. So option B is correct. A minus I is invertible matrix. You people tell now. Correct or false? Tell first. True. True means answer is correct or incorrect. It is invertible. Okay, fine. So A minus I is invertible. You are saying, but from here, see, no, A minus I is invertible. So then this is false because they are telling that A minus I is invertible. Okay, correct. Then this is true. Okay, this is a true statement. So option C can't be correct. Now why it is like this? See here, guys. We have got already this, no, A minus I ka whole inverse. Or else this step only see, a minus I ka whole square is equals to a minus I we are getting over here. Now if I multiply this both the sides by a minus I ka whole inverse, we'll get nothing but what? Or else let us consider here only. Here only if I take the determinant value on both the sides, determinant of a plus I ka whole square is equal to what? Determinant of a minus I. Correct? Now determinant of a plus I ka whole square. Is it equals to 0 or not equals to 0? Just now we had told over here, see, determinant of a plus I, we are told not equals to 0. Determinant of a plus I ka whole square, or else we can tell determinant of a plus I ka whole square is equals to what? Determinant of a minus I. Now whatever this is there, this is not equals to 0. Correct? This determinant. Fine. So whole square is also not equals to 0. So from here we can confirm that this is invertible. If this is invertible, then for sure this is what? True. Okay. Next question. Let a be equal to 1101 1101, and PB is equals to cos pi by 6 sin pi by 6 minus sin pi by 6 cos pi by 6, and QB is equals to, this question also you might have seen. Okay, if Q is equals to PA P transpose, then P transpose Q 2013 P is option A 1 2013 01, option B 0 2013 01, option C 2013 0 2013, option D 0 2013 2013. Yeah, right. Solve, guys. 1 minute, I'll be back. Yes, option A. Okay, fine. So see over here. Uh, Here P is equals to cos pi by 6 value is nothing but what? Root 3 by 2. Correct or no? This is 1 by 2. This is minus root 3 by 2. And this is 1 by 2 over here. Correct? So if we see over here, P is this matrix. A is what? 1, 1, 0, 1. Now if you people remember guys, A is equals to 1, 1, 0, 1. A square will be equals to what? 1, 1, 0, 1 multiplied by 1, 1, 0, 1. This is similar kind of matrix guys. We had seen this one example. So if we see over here, we'll get 1. 1 plus 1 will be 2. And again 0. And again 1. So if you see over here, this and this element will always remain same. Sorry, sorry. Here, these three elements will remain same. What will change? This will change. Okay, only this element. So if you see Q is equals to PA, P transpose, they are telling. Now this kind of matrix, if we see, it is kind of rotational matrix. I had told you, yes or no? Cos theta, sin theta, minus sin theta, cos theta. So it is an orthogonal matrix. Correct? If you want verify here, P transpose is equals to what? Root 3 by 2, 1 by 2, minus root 3 by 2, 1 by 2. Okay? So P into P transpose will be nothing but what? Just multiply this. See, root 3 by 2 into root 3 by 2 will be 3 by 2 plus 1 by 2. 4, no, this multiplied by this. So root 3, hmm. So what we'll get here? Root 3 by 2 into root 3 by 2 will be 3 by 4 plus 1 by 4. Okay, correct. So it will be nothing but what? 4 by 4, which is equals to what? 1. Here multiply now. Minus 3 by 4. This into this will be nothing but what? Minus 3 by 4 plus 1 by 4. Okay, here I have done the mistake. It should have been 1 by 2, no? Sin pi by 6 is 1 by 2 minus 1 by 2. So now if you multiply, you'll get it correct. Okay. So see, minus root 3 by 2, and this is root 3 by 2 again. So this is also root 3 by 2. Okay. So if you multiply now, this will get 0, 0, minus of minus plus 1 by 4, again this, so this is 1. So P into P transpose is equals to what? 1001, which is nothing but what? Identity. Now they are telling Q is equals to PA P transpose. Q to the P transpose Q to the power of 2013 P is nothing but what? They are asking. Correct or no? So if you see Q to the power of 2013 will be nothing but what? I have to go on multiplying PA P transpose, PA P transpose, PA P transpose, so on up till how many times? PA P transpose. Okay, like this I have to go on multiplying. Correct on how many times? 2013 times. Now if you see this value, this value, okay, this value it is nothing but what? I. Up till what? This value it is all I. So remaining is nothing but what now? Remaining is nothing but what? P, how many times A will be multiplied? A is there, A is there, A is there, A is there. A will be multiplied what? 2013 times. P transpose, correct? So here we have Q 2013. Now multiply P transpose on both the sides because they are only telling, see, we need the value of what? P transpose Q 2013. So P transpose, if I multiply, here also P transpose, and then P over here, then P over here. This value is again I. So P transpose Q to the power of 2013 P is equals to what? A 2013. And this value is nothing but what now? 1 2020 13 only, no? Yes. Okay. And 1 0. Their option 0 and 1. answer option A is correct. Okay, guys. Fine. So we'll end the class over here. Fine. Next class, we'll start with determinants. At last, if we have time, again we will do the problems. Okay. Fine, guys. Any doubts you people have? No doubts. No?